Welcome, ladies and gentlemen, to Applications of Equations. Problem 1. My name is Mr. Joshua Davis, and you can find me at mathhealer.com. Let's begin. A salesman selling popcorn made 57 sales during one evening and took in $128.65. Part of the sales were $1.75 bags and the rest were $2.60 bags. How many sales did he make at each of these prices? So one more time. A salesman selling popcorn made 57 sales during one evening and took in $128.65. Part of the sales were $1.75 bags and the rest were $2.60 bags. How many sales did he make at each of these prices? Well, let's move in and take a look at our solution. Okay, ladies and gentlemen, in this case, we're going to use some labels here, some variables. Let X equal the number of bags of popcorn that were sold for $1.75. Again, let X equal the number of bags of popcorn that were sold for $1.75. Let Y equal the number of bags of popcorn that were sold for $2.60. One more time. Let Y equal the number of bags of popcorn that were sold for $2.60. Now we have the equation X plus Y is equal to 57. This is the total number of bags of popcorn. So he had a total number of 57 bags of popcorn, and they were divided up into two different pricing sets. Some bags were $1.75, other bags were $2.60. So this equation represents the total number of bags of popcorn that the seller had. Well, now in this case, we decided to solve Y in terms of X. We wanted to get the Y by itself. So I added negative X to the left and to the right. On the left side, the X is canceled. And upon adding negative X to the right side, Y is equal to 57 minus X. So if we know the number of bags of popcorn that were sold at $1.75, we can subtract that number from 57, and that will tell us the number of bags of popcorn that were sold for $2.60. So now here's what we have, that the sales equation is $1.75 times X. X represents the number of bags that were sold at $1.75 plus 2.60 times Y. This expression represents the number of bags that were sold for $2.60. Now we add the revenue from both cells, and the revenue added together should equal $128.65. Well, right now we have an equation here in two variables. We need to eliminate one of these variables. So based on what we did earlier, we will take the equation Y equals 57X, and we will substitute this expression in place of Y. We will use the substitution property. Excuse me. Okay, I'm back. So yes, we're going to use this equation, the expression, and substitute that in place of Y so we can get an equation in one variable. So here's the result of substituting 57 minus X in place of Y. Well, now we have an equation all in one variable, which will allow us to easily solve this equation. Let's go to the next page. Now, after multiplying the expression 57 minus x by 2.6, we end up with 1.75x plus 148.2 minus 2.6 times x equals 128.65. So this is what we get after multiplying the expression 57 minus x by 2.6. Now we see here on the left side that we do have like terms. We have 1.75x minus 2.6x. So after combining those two like terms, we now have the equation negative 0.85x plus 148.2 equals 128.65. Well, now we need to get the negative 0.85x by itself. That means we need to eliminate, we need to get rid of the 148.2 that's right now here on the left side, because this is not a variable expression. It's known as a numerical expression. So I want to get the variable expression, negative 0.85x by itself. So I have to eliminate 148.2. And this is how I do it. I will use its additive inverse. The additive inverse of 148.2 is negative 148.2. So I add negative 148.2 to the left side. Now, because of the additive property of equality, and these equations are like scales, in order to maintain the balance, I must add the same exact amount to the right side of this equation so the equation remains in balance. So to the right side, I add negative 148.20. Well, here on the left side, 148.2 and its additive inverse, when we combine these, they cancel. I end up with negative 0.85x equals, after taking the difference between 128.65 and negative 148.2, we end up with negative 19.55. So right now we have negative 0.85x equals negative 19.55. Now let's move on. So now we need to get the x by itself, but x is being multiplied by negative 0.85. So in order to get the x by itself, we have to undo the operation of multiplication. So since x is being multiplied by negative 0.85, the opposite of multiplication is division. So we will divide both sides of the equation by negative 0.85. That's called the division property of equality. Whatever operation I do on the left side, in order to maintain the balance of the equation, I must perform the same exact operation on the right. Now notice that the negative 0.85s, they divide into one another once, and the negatives cancel. On the right side, the negatives cancel. And here we now have 19.55 divided by 0.85. Well, now after solving for x, we find out that x is equal to 23 bags of popcorn at $1.75 were sold. So now we found the number of bags of popcorn that were sold at $1.75. Taking that number for x and substituting it back into our equation for y, we have y is equal to 57 minus the 23 bags at $1.75. And we see here that 34 bags of popcorn at $2.60 were sold. So once again, we now know that 23 bags of popcorn at $1.75 were sold, and 34 bags of popcorn at $2.60 were sold. Ladies and gentlemen, please let me know if this instructional video was of help to you. Thank you. My name is Mr. Joshua Davis. My website is matthewlaw.com. Thank you for joining me. Have a very pleasant day. Thank you.